Hi. Hi everyone. Very good afternoon to all of you. I am very happy to welcome you all into this video meet. I am Unikrishnan, co-founder at Zoid Labs. We have been working on solutions and technologies which empower makers and innovators. So we started off with a mission to make innovation hardware available to each and everyone. So we all know when it comes to product development, we have to go through many different iterations, development cycles. It's a big challenge for any innovators who start with the product development. And it's especially true when it comes to products which involve electronics. Electronic product development is a very challenging task. So at Zoid Labs, we have come up with a desktop assembly suite which will enable and empower people to realize their own hardware prototypes quite fast, cutting out cycle times and all those things. So today, my colleague and co-founder Ajit will be addressing some of the challenges in hardware prototyping and how it can be addressed by PlacerBot. Before we actually go into the video session, I would like to highlight some of the features of this particular platform which we are using for this video meet. So you could actually interact with us during this presentation. On the right-hand side panel, you can raise hands, and you can also, like chat, you can use the chat feature, and you can also raise questions. If you have any questions, you can just write your questions out there. I'll be able to hand it over to the presenter and raise hands. All those features are available to interact with us. So please do use those features to interact us with during the presentation. And our speaker for the day, Ajit, is alumnus from IIT Madras. He has over 35 years of experience in R&D and product development in different technology areas like electronics, embedded systems, and software. He has worked in many companies of repute in India and outside, multinational companies like Xerox, IBM, Digital, etc. And without me taking much time, I'll hand it over to Ajit. Ajit, over to you. Thank you.
Okay, thank you, Uni. Thanks. And again, my warm welcome from Zoid Labs team. All of us are happy to have you here, and we have something to present before you. So let me start my presentation, and it's all about hardware development, prototyping, the pains there, and how PlacerBot Suite can help you address all those challenges. So let me start sharing my presentation at this point. Okay, give me a minute, please. Okay. Right. Okay, I hope the screen is visible to all of us. So the question here we are going to discuss is all about developing electronic hardware and specifically the prototyping angle. And surface mount electronics, as you know, is one of the challenges today because most of the parts come in surface mount, and handling those surface mount parts is not easy, and we make it easy with PlacerBot. So that is the message that we want to share with you today and put in front of you how PlacerBot does a good job for you. Okay, so we begin with a video message from the former CEO of Kerala Startup Mission, Dr. Saji Gopinath.
Very happy to see that PlacerBot, we can PlacerBot of the Zoid Labs, is getting launched at the national level today. We are actually seeing the way Zoid Labs is developing this very unique product, perhaps the only desktop-based SMT system in the country. As a consumer of this, Kerala Startup Mission and Maker Villages use this for the benefit of innovators and startups within our ecosystem. These innovators requires very affordable but accurate solutions which can actually reduce the cycle time substantially on their experimentation. At a very small scale, it actually provides you an entire SMT ecosystem so that the innovators can actually create small batches of products which can actually be developed further at their prototyping stage. Sure that this is a revolutionary product which will help students, startups, innovators, and any hardware developers to experiment, to develop prototypes, and to ensure that a large number of new products get developed through that.
Right, so that was an inspiring message. Thank you. And we look at the topics for today. So we will look into the aspects of prototyping and testing, which are very critical parts. And why is it critical? We look into that. And then we look at the challenges in managing prototyping with surface mount. And there are several pain points, and whether we can get by outsourcing those pain points or not. Right, and we will give you an overview of the methods and tools for PCB assembly in surface mount prototyping, and certain pitfalls and challenges, things to watch out for. And we'll also be sharing with you how PlacerBot suite has features which can help you make this job a little bit less painful or successful prototyping activity for you. Right, so let's go further. You have an idea, that's where you start. For example, this is a smart tennis racket into which some electronics is built, and it picks up embedded sensors will pick up some motion signals and so on, and you analyze that at the back end to improve the game. So that's the idea. It's already an existing product. So you want to convert that idea into reality, you have to go through several stages of work. That is, you have to prove the design concept, then go into detail engineering, and build a prototype and test it, and probably several cycles of this detail engineering and prototyping testing activities before you can go into manufacturing issues. And these are the fail fast signals which come out of these stages. So the importance of prototyping and testing is manifold. One is that it is a source of signals which direct the further stages of your iteration, whether you want to go back into more detailed design and come back, or you're ready to go forward, or you want to fix something within your iteration stage and proceed forward. So, or do you fail fast? That is the source of the signals, and it's a very important cycle because it's a cyclic activity, a repeated activity, and anything that you do here, if you get stuck for many days, many weeks, you do it several times, you probably kill your time to market. So there's a very critical phase of your development. And if you have external dependencies, like a vendor who is playing with you, not delivering in time, that can be very, very bad. It can affect your overall cycle badly. And it's very important, therefore, to have the right strategy for prototyping and have the right tools and the methods, and to be able to be in control. So that is where PlacerBot suite comes in, and we want to give you that control. Right. So this is an example of a module-based prototyping. So if you connect a bunch of modules, this can be at best a proof of concept. This is not a product intent, because all these modules cannot fit into the tennis racket handle, right? So this is not the PCB that you want to intend to put in there. That activity you have to do using the prototyping on the target PCB. So that is what we are interested in. And there are a few good to haves when you're doing that. One is to do incremental prototyping. That's very useful to cut your cycle time, to crunch your PNT, prototyping and testing activity cycle, to as short as you want to. Okay, the second aspect here is you want to develop hardware and software. You might have some software going onto your hardware, so these two things can go in parallel. If you can do that in parallel, then again you try to crunch the cycle time by making things go in parallel. And you can generate early feedback for your manufacturing stage. So let's look at the key activities and the key parts of this PCB-based prototyping. First of all, you have to have your CAD design, and you come out with these Gerber files, which you're all familiar with, and you send it to fabrication. And the fabrication people would give you back a bare PCB in which no components are mounted. And then you take that and populate the surface mount parts. And at this time, you make use of the placement files, which tell you where the parts go, what is the rotation angle, and so on. And you populate the surface mount parts, and you then populate the through-hole parts and inspect and test. And of course, you might inspect at various stages. It is useful to inspect at various stages. So this is the overall flow of things under which we carry on with the further discussion today. So I will give you a few points on the benefits of incremental prototyping. So you all know that when we do a PCB, we are not sure of all the parts. Our confidence level is not the same on all the parts. For example, this the red ellipse marks out a certain area which is a layout sensitive kind of area, which is actually a output stage of an RF feed coming from here, a balanced feed being converted to a single-ended output going to an antenna or a coax kind of thing. And this is like a ballon kind of stage made out of passives. And this area is very layout critical. If you mount your passives at different angles, you might get different results. For example, the inductors could have parasitic mutual coupling and so on, and the capacitance values have to be chosen carefully. The track widths and everything have to be monitored properly. So this might be a problem area for you, and you might also want to evaluate this kind of circuit with different options. So maybe the capacitor values, you want to try out different values. So when that's being the case, there's no point building the whole PCB as a whole and trying to characterize only one part of it. Then you're wasting your components, and you're probably holding up somebody else who also wants to use the PCB, and you've spent money and time doing the big bang thing, where you should be actually focusing on incremental and get your problem fixed in certain specific areas. You can focus better, be more productive. So this is another example of incremental versus big bang. So this PCB, I've taken an example of a mixed signal PCB, which has some analog portions. All the blue stuff is analogs, and this is all the digital processing. And typically, this kind of a PCB would also have a split ground plane, which is analog ground plane and a digital ground plane, to keep the noise out of the analog stage. And when you're grappling with this kind of a design, the analog designer might be interested more to check out these channels, and all he needs is one channel to be populated, so he can characterize his channel. Whereas the DSP guy would want this piece of the thing done so that he can do the software on it and test it, and he can do on his board without the analog channel. He can inject some signal into this part and proceed. And the guy who's worried about the noise part, he might just need a PCB with the minimal stuff put in there. He can do current injection into the digital ground plane and see how the analog plane is picking up that noise or not, and how much it is picking up. So this again is a scenario where incremental can speed up your cycle time tremendously, and also with hardware and software co-design. So I told you now that what I told you now is that the incremental method has a lot of benefit. And when you're doing product intent prototyping, these are all the challenges you will be facing. Your clock is ticking, and you're dealing with small parts, and your intellectual property has to be protected. And if you have loss of control, you are in a big soup, right? So let's look at some of these challenges. One is the surface mount parts are very, very small. So what you see here is a through-hole part, which is fairly big, and the 0603 is about 1.5 millimeter long, and 0402 is 1 millimeter long. This is a 0.6 mm long and 0.3 mm wide part, 0201. And currently we can handle in our PlacerBot system 0201 part. Okay, and these parts, smaller and smaller parts, require usually high-end machines, which are very expensive machines to handle. And we do 0201, which again many other smaller machines don't handle. So this is a challenge, handling these tiny parts. And when you have tiny BGAs like this 2.5 millimeter part, where all the pads are below, and if you're going to mount it with a tweezer, you can't, because you can't see these balls, and 0.4 mm pitch is tricky to handle. And what if one of these things flies off your tweezer? You may not even be able to find that part again. Forget about getting the orientation right. So with tweezer, you can't do much. And to show you that it can't be done very easily, there's an example of somebody replacing an 0603 SMD LED, which can be done. For repairs, small repairs, it is okay to do, but beyond that, it is not repeatable, and the business gets very risky and non-repeatable. So let's look at a video of that technician. An experienced technician is soldering 0603's LED. As you can see, this video also has a cut, so there's some time which went by swapping the left and right hand, which you don't see. So it's a tricky thing, because the tweezer can stick to one side, and the flux is also wetting the whole system. So very difficult. So we don't recommend you to do that. What we recommend you to do is a process similar to what the manufacturers do, which is the assembly houses do, is to use a stencil pasting and placing the components on top of the paste, and then cooking it in a reflow oven. So that is a good repeatable process. And it's very easy to get stencils manufactured. When you make your bare PCB, you can also order along with that a mini stencil, not the full framed stencils that the fab houses use, but a cut stencil, which is easy for you to manage, store, and so on. And applying the paste on the stencil is very easy, can be learned easily. And if you make a mistake, you can wash off that paste with alcohol, and you can start again. So you can do a few rounds, you'll become an expert at it. So this is a recommended process that we ask you to follow. And we are also, by the way, coming up with a paste injection machine, which will make this even easier. It's still in development. Okay. And the placing of the components can be done manually, which we don't recommend. But if you want to do it manually, you can do that. It will take you a long time, and you have to worry about the solder paste drying up while you're placing the components one by one and getting the orientation right and so on. It's very tedious, but we have automation to help you there, and we'll be showing you how it is done. And the last part is the reflow soldering, right? So these are the 4 stages. We have used an inspection system in our PlacerBot to get these images. And the first one on the left is the bare PCB. You can see the pads are shining. That is the copper, plated copper, on which the parts will be placed. And the right side shows you the paste being applied, having been applied on the PCB through the stencil. And I'll show you a video how that is done. And this below here on the right side is after the components have been placed by PlacerBot Pick and Place. They've been placed here. You can see the components, and this is the final picture after it comes out from the reflow oven. Here it has been soldered. Now you can wash this with IPA, alcohol, and so on, and use your PCB. So these are the 4 stages, and these pictures have been captured from the inspection feature of PlacerBot. So which understands after you have done the fiducial setup, which I will explain later, it will know where the components are. So you can say go to R1 and inspect that area. Go to R1, inspect that area after pasting, and so on. So this is very useful, so that you catch the errors ahead of time before the problems happen. Right. So this video will show you how solder paste is applied. So you align the stencil on top of the PCB, and then you can put the paste on it, and then you drag the paste down using a squeegee, some sort of credit card or some squeegee kind of device, and the paste flows into the pads through the small holes in the stencil. Now the paste is already applied, and you can just carefully take out the PCB. It's been held in position by surrounding PCBs used to hold it in place. And now you have the PCB which is on which the paste has been applied accurately. So now we are ready to go for placement. Right. So this is again a small BGA, 2.5 millimeter square. Right. So after the parts have been, after the paste has been applied, we have to place the parts manually, or better with automation, especially when you cannot see the pins. And then we go for reflow. So now let's talk about the reflow part, and we'll come back to the mounting part again. And this is the picture of a reflow that we did a few years ago, and we had purchased a so-called desktop reflow oven, which finally turned out to be a use and throw oven. And the results are shown here on the upper picture. You can see the reflow results were pretty good. In the top corner, the soldering has been done fairly well. At the bottom, you see the soldering has not been done satisfactorily. There are still dry things, and there's barely a joint here. And we have to touch all these points with the soldering iron, and that's not ideal. So after we got these kind of results, we we looked at the reviews on the internet. We discovered that this is some sort of a scam. These ovens don't work really well. Often they don't work, satisfactorily. So we built our own reflow soldering oven, which is our second product, and it can handle lead-free and leaded solder paste. Can go up to 300 degrees Celsius, and we can operate it from a smartphone connected over Wi-Fi, and we can make it run any profile that we can select the profile. We can also upload to the system a profile that you can design, a new profile. You can upload that, and it will run through the profile, following it as well as it can. You can see it's pretty good. And then you can take the PCB out after a few minutes of this reflow run. And this is very useful for a place like a makerspace, where maybe some of them are placing things by hand on small boards. But with PlacerBot Pick and Place, it's even better. So it's an essential thing for you to have if you're doing anything with surface mount, right? And the results here, after the reflow has been done, we can see the small BG has been mounted, and now you can test your PCB. So that is the reflow. Now we will go back to the placement aspect. So I mentioned that manually also it's possible to do, but at the end of the day, it may give you all the solder paste which is dried up, and you might have a pain in your shoulder. So you might have 2 problems, and you may get the orientations wrong because when you do something very tedious, you make mistakes, right? And some chips will fly off. Then you have to go hunting for them, and poor repeatability. So this is not at all recommended. And you may ask, what if I outsource this process? Well, you could outsource this, hoping that the pain is out of your hand, but you will pay in another way with increased cycle time. And that is very important to crunch that cycle time, and you would pay for it severely. And the loss of control and your IP may be leaked to the vendor because you have to supply them the bill of materials, all your design files, and so on. So there's a possibility of IP leak and part overages because you have to pay for the wastage. And most importantly, it will kill your prototyping strategy. You cannot do incremental when you're outsourcing whole board assembly to an assembly house or even to a manual assembler outside. It's very difficult to make them do incremental assembly, and your cycle time will be killed anyway because you're queued up behind some other jobs they have. So you will be in the end the loser, and it impedes your hardware software co-design strategy as well, and you lose some lessons that you can learn by doing it yourself in-house. So outsourcing is not recommended, but of course when you're doing mass manufacturing at volume scale later on after your prototyping everything is successful, you can do outsourcing. You should, in fact. But you can outsource the fabrication of the bare PCB. That is a very good thing to outsource because there's no IP leak there, and it's a messy chemical intensive process, and you can get it done very fast. For example, in 7 days time, you can get a small PCB made, 10 pieces for around 2,000 rupees. So that's good. And so we recommend and encourage you to do that. You can also get your stencil made at the same time. But as far as assembly is concerned, at the prototyping stage, we recommend that you don't go for external assembly. Try to control the process by doing it in-house, right? And if you want to assemble a PCB in-house down to let's say 0201 level, traditionally you use equipment like this, but then this is not something that even a maker facility or incubator can afford because you need a room to place this thing, and it costs a lot of money, and you need an operator who can put your job into it, and they would probably take a day to put your job into it and run it, and you need parts in reels and reels of parts which typical small innovators don't buy. So this is a problem, and we solved that problem with PlacerBot suite. So the picture you're seeing is the PlacerBot pick and place machine, and the stencil thing I mentioned that you can do, and the reflow oven from PlacerBot Reflow. So this combination lets you do the dream job of prototyping on your desktop. So this is very much possible, and we have also done this ourselves to build the boards that we need to build. And the automation in terms of the paste injection machine for stencil, that's also coming up. So we'll talk to you about that in probably another session. It's work in progress. So this is possible.
We have been using PlacerBot over the last 2 years in previous projects, and we find it is very convenient, and also we feel anybody can easily learn and start working on it. And this is one of the small board that I think we did last year. And so, considering the total time that we need to send this to a fab house and get it back, and also follow. So, when we look at all these, we think the PlacerBot is actually giving us a big advantage on time as well as usability. When you look at the modern startups working on niche technology areas, one of the main parameter is the IP protection. So when we give away the designs and our drawings for the fabrication outside, it is not easy to keep it traceability on the IP aspects, and also it may take time for the course of complete formalities related to registering an IP. So most of the things when we need to do testing, fabrication and testing and validation, 1 week time. Definitely we need to have something like PlacerBot. PlacerBot will be a great to all the startups and the R&D systems.
Okay, so we take a quick look at PlacerBot. It fits on your desktop. It's self-contained. It has got its own vacuum system. You don't need to attach another computer. You just need to connect the monitor and keyboard, mouse, and you can input your design files through a USB stick, and that is the PCB size it handles. Fairly good for most of the jobs, and it accepts components in cut tapes and trays, which is the small quantities that you typically use, and we can also feed it with reels, and it comes with several feeder types, and I'll show you those feeder types later, and it comes with a QR code system to make the data entry very painless and error-free. So that is a feature of our system, and we can handle small passives like 0201, fine pitch ICs, 0.5 mm pitch, QFP, QFN, and so on. And it has an auto nozzle change, so you don't need to mess with manual nozzle changing. And it's got a dual vision system and a friendly user interface. So let's walk through some of the features. So it's built for prototyping. And the feeder area, the so-called feeder bay, can be pulled out to put in your feeders. That is a feeder bay. And that is the PCB area where you put in your PCB for populating. And this is where you put the IC trays. And the front, you have the automatic nozzle changer from where the nozzles will be picked up automatically. And it's very easy to move the system. We don't need to type in numbers and so on. Sometimes you have to move the machine to a certain part of your PCB for doing the fiducial work. So it's all click and move. So anybody who can use a graphical user interface, right click and move, will be able to use it very easily. So you can see that movement, right? So easy to navigate. And it takes components in all these forms like passives in paper tape, plastic tape ICs, or loose ICs in a tray. And we have different types of feeders, like the eco feeder, which is a cost-effective feeder with automatic mechanical advancing, or you have a manual feeder, again another cost-effective feeder with manual advancing, an electric feeder with automatic advancing motorized, and a strip feeder for very few number of components if you want to feed a small length of strip of tape, or IC trays in various configurations for putting your ICs. So feed can be given from all these things, and you can also attach a reel and feed the reel tape into the feeders. Right, so let's look at the feeders in action. So this is the eco feeder, which is got a spring actuated wind-up mechanism, and it's a patented design from us. And this is a manual feeder, and it's useful for advancing it manually if you need a small number of parts and you want to control the advancing manually. And this is the electric feeder, which can operate without the mechanical advancing, and it comes in two parts. You can snap the cartridge portion to it to attach the upper portion which carries the tape. And this is the strip feeder for very short length of components. Sometimes you have that in prototyping, and you can peel the desired quantity and you can stick it into the machine and it will pick from there and place it. And you also have the IC tray, different configurations of IC trays. So we can feed ICs in loose. We can also feed ICs sitting in tape, of course. Okay, those are the feeders. And how do we load these feeders? That's made easy through the QR code system, which you can see now. So you pull out the feeder tray, the feeder bay, and then you can put the feeders in and fasten them one by one. So that is how you load the feeders. And you can notice the QR code in front. You see the QR code, that is what is scanned to identify the component which is loaded into the feeder. So that makes your component identification error-free, painless, and fast. So you can actually swap a lot more feeders. As the job is finished, you can add in more feeders and continue. And QR codes are used, makes it easy to change the feeders. So really, this number of 14 feeders that we support is not a limitation, because you can quickly scan again and get new feeders into the system when you're finished with one feeder. So the parts which are identified are automatically added to the feeder table. So the system knows what components are available for picking and placing. Right, so that is the use of QR code. And of course, you can feed your design files, as I mentioned, from a USB stick. So we accept Gerber files and we accept component placement lists in all the typical CAD formats from various CAD tools. Right, and this is a kind of input where you input your Gerber files and pick them up, and you can see a visualization of your PCB, and you know the orientation is correct and all that. You can verify and proceed further. Now there's a video message.
PlacerBot is one of the finest process innovation offering I have come across in our startup ecosystem. We all know when we design an electronic circuit board, the fabrication and process prototyping is a challenging and time-consuming process. With the modern surface mount parts becoming smaller and difficult to handle, it requires high levels of precision and skill. PlacerBot has made this job easy with some kind of automation through a desktop SMD assembly suite. It will help the innovators drastically cut down on their cycle time for product development and focus more on the creative aspects. I will recommend PlacerBot to every TBA, to every research department of a technical institution who would like to encourage their innovators, the researchers and students to convert their ideas into final products in the shortest possible time. I wish them all the best. Thank you.
Okay, so now look at some of the typical errors that you have in assembly. especially when you get it down outside through a manual assembly process. You often find the wrong part has been mounted because of human mistakes, and sometimes you find that the parts have been mounted wrongly with the wrong orientation. This may even happen in automated assembly, and since prevention is better than cure, we give you some features within the PlacerBot machine to avoid such situations happening. And one of the reasons of assembly going wrong, there are two main reasons. One is both of them can be blamed on standards. And one of them is the standards, differing standards of footprint libraries. There are two level A and level B standards. And the other part is because of the orientation of the parts as delivered on tape. Again, there are many standards which may conflict. So, for example, you look at this part, which can be coming in this orientation. Now, this is a picture of the tape, and these are the holes on the tape. And it could be coming in this orientation or this orientation based on the naming of the package is for the same part. So this is a problem. And sometimes the vendors also change their mind. They change the quadrant on which the pin 1 is supposed to appear. And this is another interesting case where the same part, really the same IC, can be supplied on two different styles with two different type of tape reels with different pin 1 orientations. But fortunately, they give you different part numbers. The manufacturer gives you part number with the AX and AZ to identify that. So if you designed your part with only this part name, you could potentially get into trouble. So this is yet another case which is a bit more involved to explain. And those are the vendors going wrong. And this is the case of the designer getting things wrong. With the IPC is, of course, the organization which governs some of these standards. And they have a level A standard which says the pin 1 of the IC coming on the upper left. This indicates the zero angle of the IC. Now, there's another standard called level B by the same standards document, 7351C. Level B says pin 1 should be on the bottom left. And different people may follow different standards. And it all depends on the libraries that you use, not the CAD tools that you use, but the actual library. And for example, look at this case where you download some DigiKey footprints for KiCad. KiCad is a CAD software, and some of these footprints will be level A. KiCad normally uses level A, but you could get some level B footprints because DigiKey has mixed them up. And a designer also could make their own footprints and not follow the standards. So this can get you into a soup. So lessons learned are check your tape and reel spec very carefully. Check the part numbers. Use part numbers for every IC that you use, and preferably the manufacturer part numbers or house part numbers mapped to manufacturer part numbers, and stick to one of the IPCC standards, level A or level B. Level A is what you would recommend. Check your BOM thoroughly, and if you're using PlacerBot, it gives you some features. What you see is what you get. So to verify that, how does it work? So PlacerBot will let you correct things even at the last minute. So we can make it go to a certain chip or certain component by clicking and clicking on the table at the correct row. So it will move there. You can see the part. You can see the IC, and then you know the pin 1 is going to be there, and you can see what the placement file says pin 1 is there. Oh, it's a mistake. So we can correct it even at that stage, and we can fix it. Now we may also have to correct the orientation on the feeder, which doesn't have to be the same, but we have to have it correctly identified. So we can visit the feeder, and if there's a mistake there, suppose the pin 1 is not there, it is supposed to be somewhere else, we can correct that in the feeder table, and they don't have to be the same. The software is capable of going through the rotation to place the part correctly, but both the source and destination angles have to be informed correctly to the software. That's important. And PlacerBot has this feature by which you can eliminate your orientation errors. And when you do your PCBs, you also have to include fiducials, which help you register the PCB correctly. And PlacerBot will be able to match up the fiducial, which can be any kind of prominent landmark on your PCB. And once the two match up, PlacerBot knows how the other components are positioned with respect to these fiducials. So 3 fiducials are recommended. And once you have done the fiducials, you can pick and place.
Time to market is one of the key challenges in product introduction. Apart from the design idea and the actual design, one of the focus area is the first prototyping. From a designer perspective, acquisition has always been a challenge, and we have to depend on a OEM manufacturer with high-end assembly process. The PlaceBot from Zoid trying to solve this problem. With accuracy comparable with commercial assembly machines, the product offers repeatable performance at an affordable cost. Even for OEMs like us, the product can reduce overheads on rapid prototypes and low volume products. So congratulations to the whole team behind this novel idea and making this a reality. Thank you.
Okay, and we can also place a batch of PCBs, that is more than one PCB, provided they have the same type, and this video shows how that is done. So the first PCB is already placed and indicated into the system's fiducial table. Now we can take in one more PCB, we can mount it side by side and indicate to the system where it is located relative to the other one. So the second PCB is also identified, and then you can collectively pick and place both in one shot, in one go. So that is useful when you want to do a batch processing of multiple PCBs. Right, so that is also possible. And picking and placing cycle can be seen here. This is a O2, O1 part, very tiny part. Pick, and it is inspected in the down vision camera, and any rotation required is corrected at this stage, and it is placed accurately at the destination. This shows a 28-pin IC, which is a 0.65 mm pitch kind of IC. This can also be handled very easily and placed accurately. And this shows a 144-pin QFP, which is a 0.5 mm pitch, 0.2 mm thin leads, and this can also be handled by our system. And the summary then is that there are several challenges in doing surface mount work. It can be done, and we need to do it better because it's part of the cycle and it's repeated activity. You need good strategy and methods, and your methods and tools should support your strategy. For example, if you want to do incremental, you can't outsource, and that will kill your cycle time. And PlacerBot enables you to do it well with minimum mistakes and in a reasonably fast and very accurate way using an affordable machinery automation. And PlacerBot finally puts you in control of your prototyping tasks. So that is a summary. And
I'm Narendra Singh Negi, head of R&D V-Guard Industries. At V-Guard, we design the electronics which goes into many of our products. So while we are developing these PCBs, we have to move from design to prototyping to final product in just few months. And with smaller and smaller assembly parts coming in, the need for automation with accuracies is something that is mostly required. So this is a challenge that all the electronics innovators are facing. And if this capability is available in-house, then there is no reason for us to go and outsource this, which is consuming a lot of time and causing delays in the projects. Last year I had the opportunity to see the PlacerBot suite, which is a desktop based assembly machine, which was a fantastic one, both in terms of performance as well as prices. And so with such a machine available in-house, I'm sure this job of PCB assembly in-house can be done very well. So this is what I'm planning to have it for my R&D for speeding up this thing, and so that it speeds up my go-to-market time. Thank you.
okay, I hope you've all got the message about PlacerBot, and I hand over the session to Uni now, and there'll be a Q&A session following this. Uni, your voice is off.
Hi, if you have any questions, please raise your hands. You can also type in the questions, we can answer them. Or you can raise the hand so we can take you on stage if you can ask the questions directly. So there's a question: up to what level troubleshooting is possible?
Okay, when you talk about troubleshooting, the main strategy that you can use is to do incremental prototyping. So if there's a certain part of your circuit which needs more troubleshooting, then you can incrementally build that, test it out. Then you don't need to troubleshoot that anymore. So you can do this in parallel. So if you have several analog channels and some DSP stuff, you can troubleshoot all this in parallel. So effectively, you're doing you're crunching your cycle time. So troubleshooting itself in terms of probing signals and so on, that you have to do your conventional way. But of course, at the prototyping stage, you can build test points and so on. But the main advantage of what we are doing here is to crunch the cycle time. And that definitely helps to accelerate the troubleshooting, because it leaves the troubleshooting to the integration stage only. Each of those pieces can be troubleshooting can be handled in parallel. Does that
I hope
answer?
that. So there's a couple more questions, like what's the minimum component size or series that is possible?
Okay, the passive that you have, O201, that is 0.6 mm long by 0.3 mm wide. That is the smallest component that we handle. And for ICs, the fine pitch ICs, that typically 0.5 mm pitch, and 144 pin TQFP and similar QFNs, DFNs, SON. We handle all these things, and the BGA, small BGA, you saw that we're doing the 0.4 mm BGA. So we can handle all this in our machine.
So there's one more question. May I request you to throw some light on the use of stencil?
Okay, the stencil is a map from your design where holes have been etched into a steel sheet, which is very small, 0.1 mm to 0.15 mm thick sheet of steel in which holes have been etched, and you apply the paste on top and you squeegee through, so the paste will deposit on the pads where you want the soldering to be done. So that is the stencil, and applying the stencil is not so difficult. You have to align it properly on the PCB and squeegee through, and the paste will come in, and then you lift up the stencil and remove it. So does that answer the question? And of course, we are coming up with a pasting solution that is in the work in progress.
So there's one more question, on the calibration of the machine. How do you calibrate the machine? I think that's the question.
Right. Okay. So yes, as you might have noticed, since accuracy is very important, it's important to calibrate the machine. And we have some algorithms, and we use some advanced techniques. I don't want to go into details of those, but we calibrate the machine. We can calibrate it, recalibrate it if required. So if you install the machine and you calibrate it once, then the machine knows how to accurately go where it needs to go. So it is built-in encoders and things like that, which help to achieve that accuracy, the desired accuracy. And you can calibrate it later if you want to. And if there's a calibration loss, the system will alert you so that it is going to operate with less resolution right now. Do you want to recalibrate? And you can do it very easily. We give you all the material which is required to calibrate. It's easy to do.
So there's another question. This is about BGA placement.
Yes, BGA placement is not a problem. We have shown 0.4 mm BGA can be placed. So that's not a problem. In the BGA, the challenge is mainly in the reflow area because of the thermal mass of the larger BGA parts and all that. The cooking has to be uniform. You have to penetrate, the heat has to penetrate underneath into where the solder balls are. So the problem really is a reflow issue. Accurate placement of a BGA is not a problem. Okay, only you're muted right now.
Sorry about that. There's one more question. How about the machine's dust tolerance? Like if it dust falls on the machine, how tolerant is our machine to that?
Dust. Okay, so we should try dust not to fall in, but there is a cover for operation, and we can clean the machine out with a handheld vacuum cleaner if you think there's too much dust on it, and or image processing algorithms are robust enough so that a bit of dust doesn't trouble it. In fact, we have some software which does lint detection and removal. So if there's a lint being picked up when the chip comes to the down vision, the lint is all understood as lint and removed. So the system is fine to operate with some level of dust, but ideally we would expect that electronic assembly is done in a fairly dust-free environment, but it is okay to have some bit of dust. So only you're muted again, but I may want to revisit that question about troubleshooting. One of our strong points is the inspection system. So suppose you have a component which has been placed, tombstoned and so on. So part of troubleshooting is to inspect the PCB. So that inspection, our software is able to help you to inspect various parts of your PCB and identify components which have been placed wrong or placed badly, if at all. Only you're muted.
Yeah, so there's one more question, like, do we have probing and testing with positional solution? Like, is there any probing solutions available to place?
Okay, Right now, there is no probing solution as such. If you talk about probing to several parts of the circuit and trying to inject signals or to measure some impedance and all this stuff, that is not the job of a pick and place machine. So that requires a specialized machine which can do that well. So instead of building a one-armed prober, that is to be revisited separately. If you want to build such a machine, which helps a lot of prototypers, we have the capability to do that, but that is not this machine. Only you are muted. Yeah.
So there is one more question that came. I have missed the fiducial points in my PCBs. Can I still do the assembly in this particular?
Sure. Yes, we have built that kind of provision into our system. We don't need fiducials as in the classic fiducial, which are a circle or square kind of fiducial, which are well defined in the industry. We can take any prominent landmark in your system, in your Gerber, as long as you know the coordinate of that Gerber. For example, I showed you the picture of a mounting hole being used as a fiducial. So you go to the mounting hole and you tell it that my Gerber 4,4 is my mounting hole, and you match the two up, and you do that for 3 mounting holes, or it could be even a kink in the track where you know the coordinate very clearly. You indicate that to our system, and it can manage with that. We have done boards without any fiducial marks on it. Not a problem. That's the strength of our system.
So for that's all the questions that we have today. I think if there is any more questions, please type in, or you just raise the hand. You can ask that directly, or Ajit, if there is anything else you want to answer, we can continue.
Yeah, so we are all available. The whole Zoid Labs team is available. Houdini and Sagar, who didn't come on stage, he's also there. So we can all answer your questions collectively, and I'm sure we can go forward and collaborate in ways to come. And we are very happy to empower this prototyping revolution. And at this stage, our country is at a cusp where we can go forward tremendously if we can take on these challenges. Electronic manufacturing is a very job-intensive area. I hope we can go forward collectively together. So thank you for attending, and please spread the message to your colleagues who may have missed this session also.
Yeah, we would like to thank you all for participating in this particular webinar, and happy to help you with any other queries. We'll be back in the launch. So if you have any questions, please come back to us. We can discuss this one-to-one. So we'll be available in the launch for some more time. Please come and join us. Thank you all.